3.4, graphing polynomial functions when it comes to it. Okay. All right. So like I said, right, let's assume we're starting already broken down. And we already talked about this before, right? How do you solve for 0? You set each one equal to 0 and just solve for x individually, right? So set equals 0, set equals 0. So x equals 4, x equals 2, that's what happens, right, when it comes to it. But we already talked this again, but I just want to get into more detail because this is the main topic of this, this section is there's real zeros. So we know when we plug in 2 and plug in 4, we get 0 out, right? That's the main focus. That's really what, what it means to be a 0, okay? So it says let f be a function and r be a real number, like 2 and 4, such that when you plug them in, you get 0 out. Therefore, it's called a real zero of the polynomial, which again, we've talked about earlier, right? These are all the possible zeros we can have, right? And figure out which one goes where. Again, the reason why we're talking about some more is because of these two properties as well. Okay. Why they're so important is because that value of 2 and 4 for this example is the x-intercepts of the graph, meaning it touches at those particular points on the x scale. So if we have just an xy plane at 2 and at 4, that tells us how to graph it individually. That's the reason why they're so special when it comes to it, okay? And things like that. Okay. Give me 1 sec real quick. Okay, sorry, my dog had to go outside. Okay, so before we're able to actually learn how to graph these situations, we're gonna do one very special rule, and it's a very trick rule when it comes to it, okay? First thing is we want to find the degree of the polynomial. They may say, okay, that's pretty easy. Just find, like we did earlier, highest degree, right? And we're done. But however, what if we give it to you like this, right? Because remember I told you we're starting at this point. Well, how do you find what degree is going to be there? Okay. So we give a little example to figure it out. So what I did is, let's suppose we want to find the degree of this polynomial here. Well, you have no choice but to literally FOIL it out. And I'm pretty sure you guys could like really no other choice, but when it comes to it for now. Okay. So what I did is I literally FOILed it out and we get to here. And now it's very simple to figure out what's the degree of the polynomial, right? Highest degree is going to be 3. It wasn't too bad, right? Okay, let's look at B now. Same process. We have this, and again, we want the degree. So again, what I did is I fold everything out. We get this, and the highest degree is going to be 4. Okay. But the process is, do we actually have to do all of that work, right? That's the main thing we want to deal with. And believe it or not, the answer is no, we don't have to. Okay. How we're going to always find the degree of the polynomial using its factor form is figure out what's the power of each individual x inside the parentheses. Because if I would literally multiply x times x times x, that gives me x to the third. Same process here. Now, this one's a little interesting because this one has a squared. So this is x squared times x times x. If you guys remember your exponent rules, that means you add them. So 2 plus 1 plus 1 gives you 4. And that little trick will always work no matter what. So for example, if we look at C and we want the highest degree, well, in this situation, we're going to have x squared times, this was going to be x to the third times just an x. So the highest degree here would be 3 plus 1 plus 2. That gives you 6. So 6 will be the highest degree we actually have. Questions on C so far, or just understanding that process? Is everybody good? All right, so if we just look at D now, so D would be x to the fourth times x to the third times x squared. So the highest degree here would be 4 plus 3 plus 2. That gives you what, 7, 9. So the degree would be 9. And that's the easiest way, if you give it in factored form, finding the highest degree of the polynomial. And just doing that little trick, and that will work all the time. Okay. All right, so now that we know that little trick, now let's actually get into the nitty-gritty of this section. Okay. So 2 major rules. First one here, and next one's at the bottom of the page. Multiplicity. Now, for some reason, this didn't work right. This is supposed to be to a power, like that, raised to the m power there. So it says if x minus r is raised to the m power, so that's raised to the m power, is a factor of x, so at, this works, we've set it equal to 0, then m is called the multiplicity of x. Okay. Now, why is this important? It's important because if m is even number, so if m is an even number, any even number possible, like 2, 4, 6, 8, so forth, if the power is even. So I go back over here, for example, if I look at D, 4 is even, 2 is even, right? That's what I mean by the multiplicity, the powers themselves. So if these numbers are even, okay, what that says is to the graph, it touches the x-axis at the value of r. So what that means is that if I do this, here's the value of r, right? That's the x-intercept. It's going to do this and just bounce right off like that. It literally touches the x-axis and goes right like a ping pong ball. And it goes into, depending on the situation. This is r, it goes this, and it just bounces right around. So we're going to have either this or that situation happening if the multiplicity or the value of m is an even number. So what happens if it's odd? So if we go back over here, like the middle one here, right? This is odd. That's a 3. That's a 3, right? Well, any odd number, right? Or even 1, right? So 1's still odd, so that works here. That's odd there. So instead of touching, it crosses the x-axis. So again, if r is an odd number, it literally just going to cross it. So if this is r, it just goes right through it. Hence what it means by it crosses the x-axis. So now we have touchings and crossings. Again, depending on the multiplicity, if it's even or odd. And that's the major thing of this first rule here. Okay. So that means if I go back over here, I can now state which ones are crossings and which are touchings, right? So for example, here, I'll rewrite it for you guys. Okay. So we know this is even, so this is going to be a touching. I'll just put T for touching. This is odd, so I know that's going to be a crossing. And then 1, right? 1 is odd, so that's going to be also a crossing. So now you can understand in the graph where they're going to cross the x-axis depending on those situations as well. Okay. So that is what this situation is saying, this stuff right here. Any questions on that so far? And I give you guys a brief picture of what I mean by crossing and touchings, right? Crosses the x-axis, so that means these are odd. So this is touching the axis, that means it's even, right? And then crossing means it's odd. So this is how our graphs are going to look like, up with the lines going up and down, across, in and out, things like that. I'll give you guys a little precursor for a couple minutes. So the next major concept is end behaviors, something called end behaviors. Okay. So the end behaviors figuring out is, what does it look like? Is it going this way, going that way? Are they both going the same direction? What's happening? And that's what we're going to be learning here, these type of rules. Okay. So the end behaviors of any polynomial is always resembles a basic graph of ax to the n. Okay. And it's always going to look like in this form. Okay. Now, what I mean by ax to the n is we're literally going to be looking at the first number and the degree of the polynomial. Hence, the more important why we care about the degree of the polynomial. Okay, so the first part is if n is even. So if the degree is an even number, again, 2, 4, 6, 8, so forth, right? The degree is even. So we got back over here, like this one, right? Degrees are even. So if the degrees are even, we're going to have one or the other happening. One, it's going to look like a W, like this, if the first number is positive. So if A is positive. If A is negative, instead of a W, it will look like an M. This is A is negative. So again, now we can go back and see. So if we go back to, let's say, the situation here. So the A is always the very first number. So it's a 1. So 1's positive. So that means we know for sure it's going to look like a W at the end behaviors. And same thing here, right? It's a positive. So here, since it's even, it's going to look like a W's at the end behavior. So the end portions are going to look like that. Right? In the middle is going to look like W's itself, like little loops. However, what if n is odd? So we have an odd power. So if n is odd, again, we have two situations depending if the first number is positive. So if the first number is positive, it's going to look like this. Okay. If it's negative, we just flip it like that. So again, it's going to be the same situation. So if it's even, both arrows are pointing the same direction, either all up or all down. If n is odd, they're both doing opposite directions at the end when it comes to. So if we go back to our little example here, what that means is like D, this will look like an odd behavior. And since it's positive, that means it's going to look like this at the end behaviors when it comes to it, kind of like an N. So a lot of stuff happens with just figuring out one single number when it comes to it. All right. So again, before we go any further, any questions on our two rules, the multiplicity rule and the N behaviors one? So all good? Okay. All right. So now we have all the information we need to graph this, okay, when it comes to it. So first off, yeah, we're gonna get rid of the y-intercepts just for help you guys out. So we're just gonna find the x-intercepts, and then from there, okay. All right. So again, the way we're gonna do this is roughly 3 steps. So first, we're gonna find the x-intercepts, which is the same thing as finding the zeros, right, of the polynomial. Step 2, we determine the zeros and their multiplicity, meaning are they touching or crossing? So that's what that means. And then thirdly, what type of n behaviors are we going to have itself? Okay. And again, these actually are not too bad when it comes to it. You guys actually may like this far easier than the other graphs we had so far. And they're pretty fun to deal with as well. Okay. So let's just do a problem so you can see how this would work out. Okay. So first off, we want to find the zeros. So in other words, set both of them equal 0 and just solve. So x minus 1 equals 0, and then 2x minus 1 equals 0. So x equals 1, and x equals 1/2. Right? Step 1 is done. We found the zeros. Okay. Now step 2. Step 2, we want to figure out what's the multiplicity and are they crossings or touchings, right? So remember, there's technically an imaginary one here, which is an odd power. So if it's odd, we know it's going to be a crossing point. So we know here is going to cross. And over here, since it's an even power, and even means we're going to be touching. So this is a touching point right there. Okay. So again, before any further, everybody comfortable with what we just did for steps 1 and steps 2. So first, just solving for x, and now second, using our multiplicity rule here so far. So again, okay. So now step 3. So step 3, we want our n behaviors. So first off, we want to figure out what's the degree. I'll just put d for degree. So this is x to the first times x squared. So this is going to be x to the third. So degree is odd, right? So since degree is odd, it's going to look like this one or that one, right? And the next thing is we want to look at the first number. So the very first number, which is right here, which is imaginary 1. So it's just, we all care about it's positive. So since it's positive, our function is going to look like this. So our n behaviors are going to look like that. Okay. So now that we have all this written down, now let's apply it to the graph itself. Okay. Now, how we're going to do this is you're only going to plot a couple points. And in fact, you only be plotting 2 points in this case. You're always going to be plotting the x values. So x equals 1, which is right here, and 1/2, which is really close to there, right? So those are 2 dots we care about. And I know on the right-hand side, it's supposed to go up, and on the left-hand side, it's supposed to go down, right? So I know that for sure because that's what that rule says. Okay. Now, in between is where we do the crossings and touchings. Okay. Because I know, right, this arrow has to go up, and at 1/2, which is right here, it has to touch. So since we're going from the bottom up, meaning it's going to look like this. It's going to touch it and just go bounce right back around. So at the 1/2 marker, I'm going to touch it and just bounce back down. All right. So far, so good with the first one. So it touches it and just comes back down. All right. I know at 1, it has to cross it. So I don't know how far the loop is, and it really doesn't matter. You can make the loop big, small, but I know it has to curve back around and cross at that point. And then finally, you just connect your arrows, and that's our graph. Again, it is just a sketch of the graph, and that's how we're going to do that. So it's just a quick little sketch going these 3-step processes here. It may not look it, but it's kind of like we had here, right? It just kind of looks like it. It's just this one's scrunched over here. We still have a loop there. So it kind of mimics the exact same template, but all these are going to look a little different when it comes to it. Okay. So any questions on our first example there? No? Everybody good? All right. So let's keep going to give you guys more practice. All right, second example. So step 1, set all of them equal to 0. So this is a trick one because this also, we have to set equal to 0 because it's a variable. So we're going to have 3 of them this time. So we're going to have x equals 0 from here, x minus 1 equals 0, and then x minus 2 equals 0, right? So that one you still have to apply to it. So he did for the next one, right? Same process there. Okay, so we set a new, so we have x equals 0, x equals 1, and x equals 2, right, as our zeros or x-intercepts. Okay, now we go on to step 2. So step 2, identify which is a crossing touching. So this one's an odd. So odd means crossing. Again, right, this is an imaginary 1 there. So that's also odd, so that's going to be another crossing. And then this one is even, so that's going to be a touching. Okay. All right. Then the last step, degree. All right, so we have x to the third here times x to the first times x squared. So that's going to be 3 plus 1 plus 2, so that's going to be 6. So we have an even degree of 6. Okay. All right, so we have an even degree. So even degree is going to be one of these two, right, because it's even. So it's going to look like a W or an M. And now we just got to figure out, is the first number positive or negative? In this case, it is -2. So that's negative. So it's going to look like a M in this case. So we know our end behaviors are going to look like that. So they're going to, both arrows are going to be pointing down. Okay. So again, any questions before we start graphing on those 3 steps? So everybody good?
I have a quick question. So how do you know that it'll be an M?
Oh,
How
because
do you like determine that?
the first number is either positive or negative.
Okay.
So if the first number is positive, it looks like a W.
Mm-hmm.
If it's negative, it looks like an M.
Oh, okay.
So
Got it.
here we have a -2.
Mm-hmm.
So it's negative, so it's going to look like an M.
Oh, okay. Thank you.
Same thing for the odds portion. If it's positive, it looks like this. That's why technically there's an imaginary 1 right there.
Mm-hmm.
So that's positive. So we have that one. But if it's a -1, it would look like this instead.
Okay, so you use the -2 to know that it'll be an M.
Yes.
Okay, got it. Thank you.
Okay. Any other questions so far? All right, so now we do the same thing we did on the top one. So we're going to just plot our points. So we have 0, 1, and 2. So we have 3 of them this time. Okay. According to our end behaviors, the arrows are going to be pointing down. And now in between is where we use our crossings and touchings, right? So if I go up this way, at 0, it crosses it. So it's going to cross there. Again, I don't know where it does, but it loops around because at 1, it has to cross this one again. So it can look like that. Again, I'm going to loop back around because at 2 now, it touches it and it bounces right off. So it's going to be just like we had up here. So it's going to touch it and just bounce right off and just connect your arrows. Something like that is our graph. It doesn't have to be pretty, as long as you have the major stuff, right? The loops, you can make them as small or as big as you like. So, all good there? Okay. All right, next one. All right, so same situation. So we have x equals 0, x minus 3 equals 0, and x minus 1 equals 0. So we have x equals 0, x equals 3, and x equals 1 as our portions. So now we're going to step 2. So at 0, it's even now, so it's going to touch because that's even. Over here, again, there's an imaginary 1, so that's odd, so that's crossing. And then the last one, 2 is even, So that's going to be a touching. Okay. All right, step 3, we need to find degree of the polynomial. So this one's going to be x squared times x squared there. Sorry, x to the first here. What am I saying? X squared. There's x squared. So this would be 2 plus 1 plus 2 is 5. So we have an odd degree now, 5. All right. So again, we got to figure out n behaviors. So going back to our portion, now it's n is odd, so it's going to be one of these two here. So if the first number is positive, do this one. If it's a negative number, use that one. And here, -3 is negative, right? So therefore, it's going to look like this. So I know my n behaviors are going to look like that. So again, any questions there? Okay, cool. And now we just select the last two, incorporate it here. So we're going to have 0, 1, and 3. Okay. So I know my n behaviors should look like that. And now to fix all this stuff in here, so at 0, it touches. So it touches it and just bounces back around. At 1, it also touches, so it's going to loop, touch, bounce right around. And then at 3, it crosses. And there we go. And that's roughly our sketch of our graph. Kind of weird, but yeah, not too bad. Any questions here at all? No? Much easier than the stuff we did before? I think so. See, graphing isn't too bad. Okay. All right, in that case, let's do our last example. So here's your last extra credit. Go ahead and find the x values and identify which is a crossing touching. I'll give you guys a quick minute or two. Go for it. Okay, looks like everybody will do it in. Okay, so looks like everybody got them. So x equals 1, x equals 6, and both touching. That's your step 2. So step 3, degree of the polynomial is 2 and 2. It's going to be 4, so it's going to be even. And since it's even and the first number is positive, it's going to look like a W. It's going to look like that. So here's 1, here's 6, and we know it looks like this. And they're both touching, so I go here, touch 1, loop back around, touch 6, and loop back around. And there is our graph. Any questions there?